This video, I will be doing chapter 11, problem number 1 from Gapenski's Healthcare Finance, edition 6, so 6th edition. So problem 11.1. Problem 11.1 starts with a question about a bond that has a 10-year maturity, a 12% coupon rate with annual payments, which is an important point, and a $1,000 par value, right? So we here's the things we know. N is going to be 10, right? So that's the number of years. The coupon rate, the coupon rate is 12%. Coupon rate is 12%. Rather than setting I to 12, you would assume I is 12 at the time of the issue, most likely, all other things equal. And then par is 1,000. Okay. So what would this look like if we drew a timeline for this bond? So we'd have something like this, and we have time 0 and then 2, 3. Do my little squiggle here to show, fast forward time. So you have year 1, 2, 3, and 10. So at time 0, assuming that the coupon rate is equal to the market interest rate, you would invest $1,000, and then you would receive coupons of 12% of the value of the par. So that's 1,000 times 0.12 would be 120. So you'd get 120, 120, 120, on and on and on until you get to year 10, at which point you'd get 120, plus you'd receive the par value back. So you'd get a total of $1,120 on the last payment. So you'd get what you're buying with this bond is a stream of $120 payments, a cash flow of $120 payments. And then at the end, you're getting a combined cash flow of one last $120 coupon plus $1,000 of par value back. Okay. So that's our basic bond. And if you were to put all this information into a financial calculator, and so you would say, okay, N is, let me just write that out. N equals 10. I, we're going to assume, is equal to the coupon rate, C. So that would be 12. Payment would be 120. And then there would be a future value of $1,000. So you're going to get a series of payments, plus there's going to be a future value of $1,000. So let me grab my handy financial calculator here. And I'm going to do all these examples using a financial calculator because that's happens to be how I teach in my class. You can, of course, do this using a spreadsheet, and that's probably a more realistic way. But for pedagogical purposes, we're going to use the financial calculator. So first things first, you always clear your TVM, and then you just plug these numbers in. N is 10, I is 12, payment is 120, future value is 1,000, compute PV, and you'll see you get negative 1,000, right? Which means that the PV is actually 1,000. It's not negative 1,000. Well, what does that mean? Well, the lesson here is when the coupon rate equals the market interest rate, then the price of the bond will be the par value of the bond. So in this case, the par value of the bond was 1,000, and so the price, which is going to be the present value, is equal to the par value. So 1,000 equals 1,000. Okay, so this is all kind of a preamble to the actual problem. So part A says, suppose that 2 years after the bonds were issued, the required interest rate fell to 7%. So that means that our starting assumption is no longer true, right? So the coupon rate is still going to be 12% because that's a contract, right? It doesn't change just because things are happening out in the market. And then the market interest rate is now 7%. What would the bond's value be? Okay. So it's 2 years later, so we've received this first coupon and this first coupon. So now what you're really buying are 8 more cash flows, not 10, right? You're going to get 3, 4, 5, 6, and so forth out to 10. So that's going to be 8 cash flows, 8 $120 payments all the way out to 10, Plus, you're still going to get that $1,000 par value payment at the end of the life of the bond. So the things that have changed here from this original, from our original statement of the problem, N is now equal to 8 because there are 8 years left on the bond. I is now 7 because the market rate is now 7, right? It's not that we don't use the coupon rate for I, we use the market rate for I. Payments are still the same because it's a contract and that doesn't change. And the future value is still the same because, again, it's a contract and that doesn't change. So what we're wondering is, what's the PV? It's pretty straightforward. So clear my TVM. N is 8. I is 7. Payment is 120. And future value is 1,000. And compute PV. And you see now I get $1,298 is the market value for this bond. So the PV is 1,298. Right. So what happened? Why are investors now willing to pay almost $1,300 for a bond that 2 years ago they would have paid $1,000 for? Well, any bonds issued today at year 2 will now have a coupon rate kind of by default equal to the market rate. So that means that new bonds issued will have a 7% coupon rate, which means that the coupons on new bonds being issued at year 2 will have a $70 coupon, new bonds will have a $70 coupon rather than a $120 coupon. So which would you rather have each year, a $120 payment or a $70 payment? And the answer obviously is, I'd rather get the $120 payment. And so investors feel the same way. And so they're willing to pay more for a series of $120 payments and a final payment of $1,000 than they are for a series of $70 payments and a final payment of $1,000. So the value of this bond increases from $1,000 to almost $1,300 because investors can't get this same kind of cash flow as they did before. Okay. So that's A. The answer to A. The value of the bond increases because the value of the bond works. Goes in the opposite direction of the change in the interest rate. So if the interest rate goes down, the value of the bond goes up. If the interest rate goes up, the value of the bond goes down. So we'll see that here in another second. Problem B. So instead, it says, suppose that 2 years after the bond were issued, the required interest rate rose to 13%. What would be the bond's value? So this is the same, basically we're just changing the interest rate. So again, we're 2 years into the life of the bond. So that means that this 10-year bond now has 8 years left. The market interest rate is 13. Remember, the coupon was still 12. And payment still by contract is 120, and the future value still by contract is the par, and that's 1,000. So now we want to know what's the present value if the interest rate goes up to 13%. Now, remember what I just said a second ago. If the interest rate goes up, the price of the bond goes down. They move in opposite directions. And this is one of those kind of crazy intuitions that is just hard to kind of bang into your head. But you've got to remember, interest rate goes up, price goes down. Interest rate goes down, price goes up. Okay, so we just plugged that data in to our calculator. So we've got to clear our TVM, as always. 8 is the number of periods. 13 is the interest rate. 120 is the payment. 1,000 is the future value. Compute PV, and you get 952. So like I said, because the interest rate went up, the price of this bond went down. Now, what's the logic? Well, new bonds issued at this point in time, at year 2, would have a coupon rate of 13%, right? So that would be $1,000 times 0.13 would be $130. So here, investors would rather get the $130 payment per period than the $120 payment per period, because 130 is bigger than 120, right? So wouldn't you rather get 130 than 120? So in order to convince investors to buy our bond that has a $120 coupon payment instead of the market $130 coupon payment, we have to reduce the price of our bond to kind of make it more appealing to investors. All right, and C says, what would be the value of the bonds 3 years after issue in each scenario above, assuming that the interest rates stayed steady at either 7% or 13%? Well, let's just bring back our 7% example here. And all that's changed now is we've moved one more year forward. So instead of 8 years left, we now have 7 years left. So N equals 7, I equals 7, payment equals 120, future value still equals 1,000, right? Contract, number of years is the nature of the reality, I is the market rate, and we're assuming that those have stayed constant. And so what is our PV? I realize that looks like a P. All right, so what is our PV? In other words, what is our price? So we just go back here, clear our TVM, N is 7, I is 7, payment is 120, future value is 1,000, compute the PV, and we get 1269. Now here's something I want you to kind of point out to you. Notice that even though the interest rate is still the same, because we've moved 1 year closer to the end of the bond, this is actually worth a little less. The 7-year bond is worth a little less than the 8-year bond. And what we're going to see is as you approach the 10th year, if you were to do this for year 4 and 5 and 6 and so forth, the PV would continue to fall closer and closer to the par value. And so let's see. Let's just do the other one. So here we have, again, we had 8. The only thing we're going to change is now N is equal to 7. I is still equal to 13. Payment is still equal to 120. FV is equal to 1,000. What is the PV? And what we're going to see is the same effect here. N is 7. 13 is I. 120 is the payment. 1,000 is a future value. Compute PV. And we get 955. 77, so 956 essentially. And notice this one is rising back towards the $1,000. So what we'll see is bonds that are selling at a premium, if this is price and this is time, as they approach, so bonds that are selling at a premium will fall down, and bonds that are selling at a discount will rise back toward the par value. Okay, that is it for that problem.